about the mole bridge, this gorgeous piece of art that you see on your screen in front of you right now. The mole bridge is an addition to our mole map that we used to do. Remember, we took a ride on the mole train. We can go from moles to grams to liters, all that good stuff. But it was limiting because we were always, confined to the same substance. Let me actually bring that up here. So here's our old mole map. We see that mole is the central thing, and it's great and it's very useful. We can go from, grams to volume to whatever it is we want to go to. But in real life, we're not going to be working with just one substance. We're going to be making reactions happen. We're going to be changing the substance. We want to know how much product might be made, or we want to know how much reactant has to be used. And so we need to be able to go from one substance to another. And up to this point, there's no conversion factor that allows for that. So that's where the mole bridge comes in. Through the lab that we did, we discovered that the mole relationship, or the mole ratio, is an equality, just like the grams over moles and the liters over moles. And so we can use it as a fraction, as you see right here, and plug it into our calculations, and that can allow us to convert from one substance to another. So the way that I kind of word that is, we have moles of A, whatever substance A may be, and that's typically what you're starting with in the question. And then we cross the bridge to get to moles of B, which is what the question is looking for. And the substance itself is the A and the B. So whatever, compound or element, whatever the question is talking about, that's what our start and want is. The moles are the units. So we can't go from grams of A to grams of B. That's not the mole bridge. That would be the gram bridge, and there's no such thing. There is a mole bridge, which allows us to go from moles of A to moles of B. And so if we add this to our old map, it looks a little something like this. And I know it looks crazy, but I promise, if you cover up, this, cut it off here, this whole section, this whole left side is just our old mole map, and there's nothing new about it. It's the exact same thing, except you'll notice that the arrows only go in one direction. They all move from left to right, because we're not going to go backwards anymore. We don't care about volume of A and molecules of A. I wanted to go from volume of A to moles of B so that I can figure out how many grams of product I'm going to get, or how many molecules of reactant I need to use up. So this is kind of the big picture, but we're going to focus just on that center there of the mole map. We're going to focus on just, I clicked on the wrong notebook, on just this mole bridge. And let's do a problem together. So you'll notice that on this page, again, this is all moles. This is only the middle of the map. You'll notice that we have some chemical reactions, and we've never had those before because we haven't needed them. You cannot cross the mole bridge without having the balanced chemical equation. Let me just get a highlighter out here. So the ratio, these numbers, these values, come from the coefficients in the balanced chemical equation. So you cannot do stoichiometry. You cannot cross the mole bridge without having the balanced equation, because that's where these numbers come from. So I've already identified what the question wants and what the question gives. That's something that we talked about before as, something we always do. It's always our first step is identify what the question gives us. It's a number, units, and a substance. And then what the question wants, which is always going to be, units and a substance. And you'll notice that now the substance is different. And that's why I stressed it so much back in the mole unit, so that, we can get in the habit of identifying that piece of it as well. So real quick, I'm just going to balance the equation. Remember, there is a balancing video if you are still kind of stuck on that. So if you need to go back and watch the balancing video, you can. Same thing with nomenclature and moles and all that good stuff. But, okay, so let's get this started. So I'm going to start the same way I always do. You'll notice that our first 5 steps is all the same exact thing we've always done. I'm not going to do anything new until I get to that mole bridge step where I have to find those coefficients. So to start, I have 3.99 moles of MgCl2. And I'm going to actually highlight the MgCl2 in my reaction because, like we said, the balanced reaction is required. And so if I can highlight that, it'll help me identify what goes where once I start, drawing my chart. And so I'm just going to do that. So I have my starting point, draw my chart. Oops. Okay, so now the question is, what do we plug in? And hopefully by this point, every single person watching this video knows that if moles of MgCl2 is here, then moles of MgCl2 needs to go down there. They need to match. Why do they need to match? Because they need to cancel out. Yes. So, that's not changing. It's never, ever going to change. That's always the case. However, what's different is up to this point, we've always said what number goes in front of moles, and everybody says the number 1, yeah, but that's not true anymore because 1 is when we're talking about the equality to grams or liters, because 1 mole equals, say, 1.01 grams of hydrogen, or 1 mole equals 6.02 times 10 to the 23rd molecules. But in this case, we're not going to have moles or grams or liters. We're crossing the mole bridge. So we're going to have moles up top. And we've never seen moles over moles before because it wouldn't make sense to go from moles of magnesium chloride to moles of magnesium chloride. That's the same thing. It's literally pointless. But the difference is we're not going to magnesium chloride. We're changing the substance. We're going to silver chloride. So before you jump the gun and say, well, 1 always has to go in front of mole, it does, except for when you're crossing the mole bridge. So when we cross the mole bridge, again, I'm just going to come over here. When I'm crossing the mole bridge, I get the number of B and the number of A, and that number comes from the coefficients in the balanced equation. So if in your work you've gotten to moles, your next step is going to moles of the next substance. So moles to moles, mole bridge, crossing the bridge, trying to get from magnesium chloride to silver chloride, and we get those numbers from the balanced equation. And just like I said, I highlighted here this 2 AgCl in orange, and here I'm writing in orange, and so I'm going to have a 2 moles of AgCl because that is the coefficient right there. And then on the bottom, I'm going to have 1, I highlight it in blue so I see it right away, 1 mole of MgCl2. Now my units on top match what the question's looking for, so I can go ahead and plug that into my calculator. And when I do 3.99 times 2, I believe is 7.98. And our label, of course, we have to have units, which in this case is going to be moles, and our substance is AgCl. Now, the units and substance are just as important, if not more important, than they've always been, because if you just said 7.89 moles or 7.98 moles, I wouldn't know if you forgot to change to AgCl, or if you didn't know what you were doing, or maybe you maybe you accidentally went to AgNO3. I don't know what you're doing. So make sure that you are including all of your labels in your answer every time. And that is the mole bridge. So you do these questions the same way. You always identify what the question gives you, and that's your starting point. Identify what the question wants, and then go ahead and cross the bridge. The next video that you can watch is the actual stoichiometry video, where we take this mole bridge and we cross it within a full stoichiometry problem. And that means that we're using that big mole map that I showed you earlier right here. So get ready for that. Whoop, whoop. Bye, guys.